Did you know that all living things have polymers? Well, polymers are large molecules made of small units called monomers linked together. Did you know that monomers are the basic building blocks of polymers, represented by small molecules or molecular units? Monomers typically possess reactive functional groups that enable them to undergo chemical reactions to form larger molecules. The words polymer and monomer came from the words poly, which means many, mono, which means one, and mero or mers, which means parts. How do polymers form? Polymers are formed through a process called polymerization, which involves the chemical linking of monomers to form long chains. There are two main types of polymerization reactions: the addition polymerization and condensation polymerization. Polymers has four different structures, namely linear polymers, branched polymers, cross-linked polymers, and networked polymers. Linear polymers possesses a straightforward structure where monomer units are connected in a single continuous chain. Linear polymers also resembles spaghetti with long chains. Branched polymers have a more complex structure where side chains or branches extend from the main polymer chain. Another meaning: monomers are joined to make long chains with side chains or branches of various lengths originating at random points from a single linear chain. Cross-linked polymers, also called as network polymers, are characterized by the formation of covalent bonds between multiple polymer chains. This interconnected network creates a rigid and strong material that is less susceptible to deformation. Cross-linked polymers, a bond or a short sequence of bonds that links one polymer chain to another to create a three-dimensional network. Networked polymers, similar to cross-linked polymers, exhibits a highly interconnected structure where polymer chains are linked together through physical entanglements rather than covalent bonds. This entanglement network results in a strong and elastic material.
Today, plastics are everywhere, and plastics are the common materials that is used every day. But what are plastics? Plastics are materials consisting mostly of naturally occurring and improved or chemically manufactured polymers, often containing additives such as fibers, fillers, pigments, and the like, which further improve their properties. Plastics include thermoplastics, thermosets, and elastomers. This could be natural or synthetic. Plastics are high polymer glass which can form into any desired shape by heat and strain. These are the materials that are based on polymeric compounds, and they often contain other additives that improve their properties. Compared with most metals and ceramics, plastics have low strength, stiffness, and melting temperatures. However, they have low density and good chemical resistance. We also have this called resins. Resins are simply the binders used by plastics, and these two terms, resins and plastics, are used synonymously. Proceeding to the classes of plastics or resins, we have the thermoplastic resins, thermoset resins, and elastomers. Thermoplastics. These resins are softened on heating and hardened on cooling, and this transition is not chemical but physical in nature. Thus, constant heating and cooling does not alter its nature. Thermoset. These resins are those that are heated during the molding process, and the heating is continued until it is fixed and hardened. This hardened material cannot be softened again, hence the setting is permanent and irreversible. So, we're going to distinguish the differences between thermosets and thermoplastics. These two materials may seem to be similar, but they are chemically and structurally very different. Like what I said, thermoplastic is a resin that is solid at room temperature, but becomes plastic and soften upon heating. Have low melting point when heated, and it will soften to a malleable state or melt to liquid state. It can be molded into any desired shape. It is reversible, for it can be reheated and molded again to another shape without causing any risk material properties. While thermoset is a liquid resin at room temperature and harden upon heating and addition chemicals. While thermoset are liquid resins at room temperature and harden upon heating or addition of chemicals. It has high melting points, unlike thermoplastic, but although once exposed to a certain temperature and cured to a solid state, their components and physical properties become set, meaning it cannot be melted back or restored. The solidification process is a result of formation of certain bond called crosslinks, which holds the molecules in place, changing the basic nature of material. Cross-linking is a process of forming covalent bonds, or relatively short sequences of chemical bond, to join two polymers. For their molecular structures, thermoplastics are linear polymers. It has weak molecular bonds and are in straight chain since it's linear, while thermosets are network of polymers, high level of cross-linking together with strong molecular bonds. The microstructure, thermoplastics comprise of elastic amorphous and hard crystalline regions in the solid state, while thermoset comprise of thermosetting resins and reinforcing fibers in its solid states. For their polymerizations, thermoplastics undergo additional polymerize during manufacturing before processing. Thermoset undergo polycondensation polymerization, and this is done during processing. Take note, thermoplastics undergo before processing, while thermoset undergo during the process of polymerization. For their melting point, thermoplastics has a lower temperature than degradation temperature, while thermoset has a higher than degradation temperature, which degradation temperature is between 500 to 800 degrees Celsius. Thermoplastics can be recyclable, while thermoset is non-recyclable. For their mechanical properties, thermoplastics are flexible and elastic, with increased resistance to impact and has its strength from crystallability. For thermoset, it is brittle and inelastic, rigid and strong, the strength that comes from cross-linking. Solubility, thermoplastics dissolve in organic solvents, while thermoset do not dissolve in any organic solvents. Going to their process on how they are made. Thermoplastics process in various ways such as injection molding, extrusion, thermoforming, and vacuum forming. That will be further explained later, and it requires a high melting point. While for thermoset, they are processed in their liquid form under heat. Involves adding curing agents, inhibitor, hardeners, or plasticizers. Lastly, we have elastomers. Elastomers maintain elastic deformations of more than 200%. They may be thermoplastics or lightly interlinked thermosets. The polymer chains consist of coil-like molecules that can be extended reversibly by applying force. Elastomers are also referred to as rubber. Elastomers are very special and very useful, for they have an amazing characteristics. Mainly their property is very elastic. Definitely. Both exhibit viscous and elastic behavior. It can be pulled and stretched and cannot be plastically deformed. Plastic deformation, take note, is a permanent changes in the polymer structure, and polymer cannot return into its original shape. Now, elastomers are very flexible, like I said, but what allows it to have this property? Cross-linking also apply here, where it have a link covalent band. Although the more cross-linking, the more mobility will be hindered. That's why elastomers are often thermoset polymers, but with minimal amount of cross-linking, which allows it to stretch but retain their structure. It also has a high elongation to break, which means it can be stretched a lot before it breaks. That is why it is referred to as rubber elasticity. Proceeding to how plastics are done, first we have here the compounding. This enables modification of plastic properties in order to fulfill a specific requirement. It is possible to change the conductivity or its flame retardation property. In their base form are mixed with additives to enhance their properties. Such additives here are resins, which I told earlier is the binding constituent which binds all the additives together. Filler. This can modify the properties of plastics to give a better hardness, tensile strength, finish, and workability. Fibrous fillers such as wood flour, cotton fiber, shop rags impart improved mechanical strength to plastics. Asbestos increase heat resistance. Mica or slate powder improves electrical properties. Plastics embedded with glass mass are known as fiber-reinforced plastics, which are very strong and can be used to make gates of dam, corrosion resistance, pipes and tanks, safety helmets, jeeps, bodies. PVC laminated to steel or aluminum are called composites. Next is we have plasticizers. Are small molecules and acts as an internal lubricant and improve the plasticity and flexibility of the polymer. Waxes, oils, stearates, and soaps. These additives are used to improve the finish and reduce the sticking tendency of the plastic to the molds. Coloring material also are added to improve the appeal, impart beauty, and to give UV protection to the finished material. Proceeding to the processing of plastics. First, we have here calendering. What is calendering? Calendering is the compounding materials that is run between two polished metallic rollers rotating in an opposite direction, while passing through the gap between the sheet is formed, whose thickness varies with the gap. This process is where materials are squeezed between pairs of rollers, reduced to their thickness to make it even. That is how it becomes a thin sheet. Or could also to produce a texture or even to laminate. Polymer granules are melted and compounded in the extrusion unit as you can see at the figure. Then squeeze into a softened polymer passing through heated rollers and finally coiling the plastic film at the winding station. Examples of these are plastics, papers, rubbers, and fabrics. Die casting, a technique used for acrylics, polyester, phenol, and urethanes. Compounded material is fed up into a die cavities made up of metals or plaster of Paris and is heated when the cross-linking takes place. Here, reusable steel dies or mold are preheated and coated with a dye release agent to lubricate and protect the surfaces of dies before each use. Next, pre-measured amounts of molten metals are injected into the die at extremely high pressure. The newly formed part is then removed from the die and the cycle is repeated after it cools. The die must be stronger than those used in the permanent mold process to withstand the high pressure injection. These can be engineered to produce complex shapes with a high degree of accuracy and repeatability. Film casting, a compounded solution in which suitable solvent is continuously dropped on a moving belt. The solvent evaporates and films are obtained. Cellophane papers and photographic films are produced using this process. Film casting is almost the same as calendary. Proceeding to the compression molding. This method is applicable for both thermosetting and thermoplastic materials. Thermoset moldings are most commonly created by inserting the solid material in a heated die prior to cross-linking. Compression molding involves molding of molten plastic through compression, which is a set that is used for thermoplastic as well as for thermosetting polymers. The process of compression molding consists of two parts, upper part of the die and the lower part of the die. The lower part is fixed, while the upper part is movable through guide pins. The lower part has the facility of heating as well as cooling. Predetermined quantities of plastic materials, that is nothing but resins, fillers, reinforcements, plasticizers, lubricants, stabilizers, fire retardants, and colorants, which are nothing but the additives of the plastic material are taken into the mold cavity. Then the two halves are closed by applying the pressure. Here, the pressure is 100 to 500 kg per centimeter square, and it is heated around 130 to 180 degrees Celsius. Finally, the curing is done. Once again, curing means heating in the case of thermosetting polymers and cooling in the case of thermoplastic polymers. Injection molding. Thermosetting polymers are in the form of liquid resins, are first inserted into a blender and then directly into a heated mold to create a shape. Formation and curing takes place concurrently in the mold. In learning injection molding, it is used for molding thermoplastic polymers, where in this matter hot and soft plastic is forced into the cavity in a steel door. The most important thing about injection molding is the shapes of the articles, may be simple or complex. The machine consists a hopper in which all the ingredients of the plastic will be taken. On the left-hand side, it consists of an Archimedean to push the materials into forward direction. Then the middle, there is a heater to melt the plastic ingredients, and on the right-hand side, we have the mold cavity. In the mold cavity, here form the molding parts maintained in the cold condition, as we already seen that this method is used for thermoplastic polymers. The polymers are formed by addition of polymerization, and these reactions are always exothermic. Hence, it has to be carried out in the cold condition to take the reaction in the forward direction. The plastic ingredients are taken into a hopper, and with the help of gravitational force, it falls into the machine. When the Archimedean screw is rotated, the material is pushed into the heater region where it melts, and at the nozzle, the temperature increases to such extent it quickly enters the mold cavity. Here, the curing is done. Blow molding. The hollow form of a thermoplastic called a parison is inserted to a die by gas pressure and is stretched towards the walls of a die. Formation and curing takes place currently in the mold. This method is used to manufacture plastic bottles, cans, vehicle fuel tanks, and other hollow forms. These plastic products are commonly produced by blow molding process. Variety of raw materials during the blow molding process depending on the container application and expected performance. The raw material in a granular form is fed via a hopper into the feed barrel, which is heated to help melt the granules, and there's a tolerant called master batch. A molten tube of plastic called a parison is extruded from the machine head and cut with a hot blade. It is then captured by a water-cooled mold. The blowing nozzle is inserted into the parasol. A blast of pressurized air is blown into the parison, forcing the hot plastic to take on the shape of the mold. Once cooled and solidified inside the mold, the machine opens. The brand new container is ejected. The container is transferred to a flasher that removes excess, known as a tail, and the excess is conveyed to the process to be grown. The brand new container is ejected.
The container is transferred to add flasher that removes the excess. And lastly, we have extrusion. This is the most commonly used thermoplastic manufacturing technique. Extrusion can serve two purposes. Provides an excellent mixer for additives in the manufacturing of polymers, which can eventually be shaped using some another tool. It offers a means to constantly form such basic forms, such in blow molding and injection molding. A screw mechanism composed of one or two screws, or twin screws, drives thermoplastic heaters and additives into a die opening to create solid designs, films, covers, tubes, and pipes. Hot extrusion is most commonly performed on a horizontal hydraulic press. Hot extrusion presses are usually rated in force capacity, which translates to amount of pressure applied. The pressure depends on the billet material and its cross-section and complexity.
Thermoplastics. Thermoplastic materials play a significant role in various industries due to their unique properties and versatile applications. This report aims to explore the key characteristics of thermoplastics, their application across industries, and their environmental impacts. Thermoplastics are highly versatile polymer materials extensively used in industries worldwide. Recognizing their properties, applications, and environmental impacts is crucial for promoting sustainable practices such as responsible manufacturing, recycling, and waste management. Developing new technologies and materials that address the environmental challenges associated with the thermoplastic could provide potential solutions for a sustainable future. Important thermoplastics. Number 1. Polyethylene. Polyethylene is a polymerized ethylene. It has rigid, waxy, white, translucent, non-polar material. It has good chemical resistance against acid, alkali, and salt solutions. Good insulating property but susceptible to organic solvents, particularly kerosene. There are two types of polyethylene available: low-density polyethylene and high-density polyethylene. Number 2. Polypropylene. Obtained by polymerizing propylene in presence of Ziegler-Natta catalyst. Superior to polyethylene in terms of resistance to chemicals and hardness. It is the lightest among all high polymers. Fibers are sued for making ropes, carpets, blankets, bags, apparels, and etc. Number 3, polyvinyl chloride or PVC. Vinyl chloride is the monomer for PVC, and the monomer is produced by direct addition of HCl to acetylene at 60 degrees Celsius to 80 degrees Celsius. PVC is colorless, odorless, non-flammable, chemically inert powder, resistant to water, light, and O2. It is widely used plastic. Number 4, polytetrafluoroethylene or Teflon. Obtained by polymerization of water emulsion of tetrafluoroethylene under the pressure and presence of benzoyl peroxide as catalyst. Has strong interchange forces, has unique properties such as extreme toughness, high softening point, high chemical resistance, low coefficient of friction and waxy touch, good mechanical and electrical properties. It is used for insulating motor, transformers, cables, and wires. Number 5, polyurethane. These are a varied range of cross-linked polymers made from two liquids, a polyol and isocyant. Soft and spongy known as U-foam, it has low thermal conductivity. It is used as an insulating material in refrigerators. It is also used in making pillows and mattresses. Number 6. Nylon. Used for making fibers for making socks, undergarments, dresses, and carpets. Strong, tough, elastic, and can be dyed easily. Possess high abrasion resistance, and is chemically stable. Plastic resin identification codes. Polyethylene terephthalate. Common products: soda and water bottle, cups, jars, trays, and clamshells. High density polyethylene. What common products: milk jugs, detergent and shampoo bottles, flower pots, and grocery bags. Polyvinyl chloride. Common products: cleaning supply jugs, pool liners, twine, sheeting, automotive product bottles, and sheeting. Low density polyethylene. Common products: bread bags, paper towels, and tissues over wrap. Squeeze bottles, trash bags, six-pack rings. Polypropylene. Common products: yogurt tubs, cups, juice bottles, straws, hangers, sand and shipping bags. Polystyrene. Common products: to-go containers and flatware, hot cups, razors, CD cases, shipping cushions, cartons, and trays. Other common types and products: polycarbonate nylon, ABS, acrylic, bottles, safety glasses, CDs, and headlight lens. Thank you, and that's all for thermoplastics.